Okay, in this video we are going to be doing two good L'Hopital's limits, so let's take a look at them. So I'm going to try to show the proper work that you would show on like a free response question. If it's a multiple choice question, you just like plow through it and get the answer, and you don't have to do all the steps. But let's take a look. So we got the limit as x approaches 0 of tan of x over x plus x squared. So first thing you want to do is evaluate the numerator and the denominator at 0 and see if you just get an answer. Because if you do, you don't have to apply L'Hopital's, you just have an answer. So I'm going to just say that the limit as x approaches 0 of tan of x is equal to the limit as x approaches 0 of x plus x squared, which is equal to 0. Now to know that, I would have to know that the tangent of 0 is 0, but I do know that. So we are good. So what we're going to do is we're going to apply L'Hopital's rule. So this is what my first step would look like. Now I'm going to actually apply L'Hopital's. So I rewrite the original limit, and I'm going to say that it is equal to the limit as x approaches 0 of, we have to find the derivative of the top. So the derivative of tangent we know is secant squared. And then we're going to divide that by the derivative of the bottom, which is going to be just 1 plus 2x. All right. Now what we do is we try to evaluate again. So you're always going to apply L'Hopital's and then try to evaluate again, because ultimately our goal is to hopefully just evaluate this thing, just straight substitute and get the answer. In this case, the secant of 0 is 1, and we know that because the cosine of 0 is 1, and secant is the reciprocal of that. So if we know cosine of 0, we also know secant of 0. So secant of 0 is 1, 1 squared is 1. So we're getting 1 over, obviously, when you plug 0 into 1 plus 2x, you're going to get 1. So overall, we get 1 for this, and we are done with that limit. Let's take a look at another one. All right, this one looks a little more complicated. The limit as x approaches 1 of 1 minus x squared plus 2x squared natural log of x all over 1 minus sine of pi over 2x. I don't know if I read that right. I think I did. 1 minus sine of pi over 2x. All right, again, step 1 is try to substitute in. So there's a couple things you need to know. The natural log of 1 is 0, and the sine of pi over 2 is 1. But we are just getting 0 over 0 again, so let's start with that. The limit of the numerator equals the limit of the denominator equals 0. This is a L'Hopital's situation. We knew that because we know the natural log of 1 is 0. That's an important natural log fact that you should definitely remember. And we also know that the sine of pi over 2 is 1. So that's where we're getting 0 over 0. So what we're going to do is we are going to apply L'Hopital's rule. All right, so to do that, we are going to do the original limit is the same as the limit as x approaches 1. Derivative of the numerator is going to give us, we get negative 2x, and then you're going to get plus, you have 2x squared times 1 over, so we're doing the product rule. 2x squared times 1 over x is plus 2x, and then you have second, which is natural log of x, times derivative of first, so that's going to be 4x natural log of x. And if you're not sure or didn't follow that, I just found the derivative of 2x squared natural log of x using the product rule. Okay, over the derivative of the bottom. So here we need to find the derivative of 1 minus sine of pi over 2x. The derivative of 1 is 0. The derivative of sine is cosine, but we have a chain rule situation. So we're going to get negative pi over 2 cosine pi over 2x. We need to evaluate this at 1 because maybe we're done. I mean, obviously the negative 2x and the 2x are just going to cancel. So we have 4x natural log of x at 1. We have that natural log of 1 again, so that's 0. And then the cosine of pi over 2 is 0. So again, we're getting 0 over 0. So we're going to state that. If you're not sure why, we had that natural log rule before. And also, we know that the cosine of pi over 2 is equal to 0. Okay, so from here, I'm going to apply L'Hopital's. So this is a two-step. You could have to apply L'Hopital's like 5 times. I've never, on an AP exam, never more than twice. Really never twice in recent memory, but still like be on the lookout for that because I do think that's very fair game. So let's do it. So the limit that we have so far, which I'm going to drop the negative 2x plus 2x, combine those, right? So we have the limit as x approaches 1, 4x natural log of x over negative pi over 2 cosine of pi over 2x is equal to the limit as x approaches 1. We're doing L'Hopital's. So we need the derivative of this. This is a product rule again. So it's going to be 4x times 1 over x, which is just 4, plus natural log of x times 4. So we have 4 plus 4 natural log of x. And then all of that is going to be over. The derivative of cosine is negative sine. So we'll have negative pi over 2, negative, and then another pi over 2 sine of pi over 2x. So this is very much chain rule. So that negative pi over 2 is a coefficient. Negative pi over 2 is a combination of the derivative of cosine being negative and chain rule giving us pi over 2. So we have this, and now we're just going to use some of the things that we already know. We know that the sine of pi over 2 is 1. We know the natural log of 1 is 0. So from here, we definitely have 4, and then we have negative pi over 2 times negative pi over 2 times 1, which is pi squared over 4. So our final answer here is going to be 16. So I wrote sine of pi over 2 equals 1 twice. I actually went back and edited that back in for some reason. But anyway, that's two really good examples of the proper work that you want to show. These would be very fair game on multiple choice, in which case I wouldn't do all the like limit of the numerator equals limit of the denominator equals 0. I would just skip that and just like plow through the kind of algebraic approaches. Anyway, I hope you find this helpful, and good luck.